Welcome back, my 7th grade class. Let's go ahead and get 8.6 done. I got all the odd ones as usual. First one says find the area of the figure. To find the area, I need to go ahead and know the formula for every one of the shapes. So let's start with the shapes that I see. I see that there's a square here. I know there's a square because this is 2 by 2 and by 2 again, which means this side is 2. So that tells me the area of a square. We'll just put area of a square like this. I know that doesn't exactly look like a square, but that equals s squared. In other words, whatever the side is, we're going to square it. And that makes sense because if it's 2, we're taking 2 square, and that's 2 times 2. And that equals 4. So now I know the area of the square is 4. And that makes sense even if you say that the area is length times width, which is all rectangles and squares. It's still going to get 4. Now let's try this next one. It's that area of a rectangle. Now this rectangle has a width of 1. And then you might think that the length is 2. But remember, this is 2 from here to here. And this is 2 from here to here. So in actuality, this is 4 across. So rectangle, the area of a rectangle, just shows area of a rectangle. That equals length times width. And that's going to be 1 times 4. That's also going to be 4. Now we just add these together. Since we have 4 plus 4, that's going to be 8. And since we are doing everything by inches, this is 8 inch. And remember to put square, because when we're dealing with area, we're talking about a 2-dimensional shape. All right? Number 2 is for you to do. You're going to need your formula for area of a circle, and you'll have to divide it by 2 to get this shape, and then your area of a triangle. Look in your notes for those. Number 3, it says, write and solve an equation to answer the question. What percent of 92 is 23? When I do this, I like to use cross multiplication. So what percent of 92? The minute I see of, I know that of goes on the bottom of my first fraction. And is goes on the top. In other words, if a number follows the word is, I put it on top. And if a number follows the word of, I put it on the bottom. I'm going to make this equal to a percent. Everything is based off of 100%. So 100 will always be on the bottom. I need to figure out what percent, that's X here, of 92 is 23. To do this, I'll cross multiply. And I'm going to show that. I think we've done this in class quite a few times. But I'm going to show that for the people who are just learning here. We're going to take 23 times 100. It has to equal 92 times X. So let's see, 23 times 100 has to equal 92 times X. I know 23 times 100, well, this is all going to equal, I can put on the bottom here, 2300 equals 92X. And now to get X by itself, I'll have to divide 92 away. Whatever I divide from one side, I divide from the other. This gives me 2,300 divided by 92. And I'm going to get my calculator here to solve that. We've got 2300. Remember, every fraction is a division problem. Divided by 92. This is going to equal 25. So X equals 25. So that's the answer to our question. Basically, 25 is 92 or 23% of 92, or 25 of 92 is 23, however you want to say it. Our answer to number 3 is 25%. All right, let's go ahead and move down. You have number 4 to do. I've got number 5. 5 says, find the surface area. Find the surface area of the cylinder. So this one says a can with a radius of 60 millimeters and a height of 160 millimeters. So let's just draw this out if we could. I don't know if they have the shape available. I'm going to check really quick. I don't see these three-dimensional shapes available. So I'm going to have to go ahead and let's just see if they got one here. Nope. All right, so I'm going to draw this out. And if I'm drawing a can, I know with a can we have a circular, right, the bottom, and then the can's going to come up, and then there's going to be a top of the can, right? So it might look something like this. What they're saying is the can has a radius of 60 millimeters. So a radius is from center of the circle to the end. So they're saying that equals 60. And this says a height of 160. That means from here to here is 160. Now the formula for finding, and it says the surface area here. Remember, we're just trying to find all the areas. So the first thing we have to do is realize if we unfold this, we're going to have two circles, right, on each side of a triangle, or a rectangle, excuse me. I don't know if you can imagine that or not, because this is going to wrap around the two circles after they fold in. And they're saying that this is a radius of 60, right? So we're going to put 60 over here again. And then they're saying that the length, let's see, and this length is not going to be from here to here. This length they're saying from here to here is 160. This probably doesn't look really, and I'm just going to fix it here because I know it doesn't look to scale what you see over here. I want you to get a good representation of this. This might look something like this. So from here to here to be 160. Right, and then they're saying this circle on each side has a radius of 60. All right, so now we're going to go ahead and find this. First thing area I want to find are the circles. I know the area of a circle is pi r squared. So the area of a circle equals pi r squared. Well, we know what r is. The radius is 60. So we're going to replace r with 60 and square it. And we know what pi is. Pi is 3.14. Well, 60 times 60 might be hard, but I know 6 times 6 is 36. And so 60 times 60 must be 3,600 because we've got two more zeros in it. Now we're going to take that and we're going to multiply it to 3.14. All right, so we've got 3.14. We're going to multiply that to 3,600. That's going to give us 11,304. 11,304. Now remember, there's two circles. We've got one circle here, and then one circle here. So we're going to have to take our answer here, since we only solved for one circle, and multiply it to 2. That'll give us the total of all the circles. So I'm going to take this and multiply it to 2. That gives me 22,608. 22,608. And remember, this is in millimeters square, so we can put m for millimeters square. All right, now we got to find the area of this rectangle. Now we know what the width is, that's not a problem, but we don't know how long it is, or do we? We do know that this wraps perfectly around. I'm going to remind everybody that this circle here is up here, right? Sorry, highlighter. There we go. So that means that this particular rectangle perfectly wraps around this circle. And if it perfectly wraps around the circle, then it is the same length as the circumference of the circle. So I can use the circumference formula, pi d. Now the other formula, of course, because diameter equals 2 radiuses, is 2r pi. Both of these are the same. All I did was replace d with 2 r's, because we know that if the radius is halfway across, then the diameter is all the way across. So we're going to take 60, multiply it to 2, right? So 2 times the radius, that's 2 times 60. And then we're going to multiply that to pi, which is 3.14. 2 times 60 is 120. Now we have 120 times 3.14. Well, 120 times 3.14 is going to equal 376.8. Now remember, this is a length. It's the length all the way around the circle, which also equals the length of this rectangle from here all the way across to here. So that equals 376.8 millimeters. All right, now that we have the length and the width, we can multiply them together. So we're going to take 376.8 and we're going to multiply it to 160. And that'll give us the answer to the area of the rectangle. So let's see, we're going to take 376.8 and multiply it to 160. That's going to give us 60,288. All right, so I found out the area of both my circles. So these are the circles. I found out the area to my rectangle. Now all I got to do is add them together to get the total surface area. So I'm going to take this 60,288 and I'm going to add it to 22,608. And that'll give me the total surface area. Plus 22608. The total surface area is 82,896. 82,000. Is that 896? Yes. 896. And let's not forget, this is in millimeters square. All right, let's move on. All right, we're coming back down to, let's see, number 6 is yours to do. That means number 7 is mine. It says find the surface area. Use the net to find the surface area. Look at this. This is almost exactly like the one we just did. So we'll be able to use much of the same principles and concepts that we did last time. Again, it says the surface area. We just want to know the area of the outside. So we're going to go with the area of a circle first. That's going to be pi r squared. We'll put a of a circle, okay? We know that pi is 3.14. And we know that the radius here is 7, and we're squaring that. This 7 times 7 is going to be 49. And we're multiplying that to 3.14. Well, 3.14 times 49 gives us 153.86. Now remember, that's just the area of one circle. So we're going to have to multiply this to 2 to get the area of both of these circles combined. So I'm going to take my answer and multiply it to 2. That's going to give me 307.72. All right, now that we found that, we need to find the rectangle. Once again, we have the width, we need the length, and luckily the the length can be found by using the circumference formula, which is diameter times pi, and since the diameter is 2 radiuses, I can rewrite this to put 2 radiuses times pi. All right, so now I got 2 radiuses. We know the radius is 7, so I'm going to put 2 times 7. And I'm going to multiply that to 3.14. We know that 2 times 7 is 14. So now I have 14 times 3.14. Well, 14 times 3.14 is 43.96. Which means the length of this rectangle from here to here is 43.96. Okay, so we'll just put it up here, going all the way across. Now we have the length and width of this rectangle. So I'm going to take 43.96. I'm going to multiply it to 5. That's going to equal 219.8. All right, now we found the area of this rectangle. Now we just need to add it to the area of the circles. So we're going to take 307.72 and we're going to add it to 219.8. Let's see, the 2 is going to come down. 7 plus 8 is 15. I'm going to carry the 1. I got 9 plus 1 is 10, plus 7 is 17. I've got 1 plus 1, that's 2. And then 3 plus 2, that's 5. And remember the decimal came down right here. My answer should be 527.52. Since this is feet, it will be foot squared. And that's the answer to number 7, 527.52 square feet. All right, let's go to number 9 now. Number 9. All right, I'm going to work these a little quicker because now we've got the gist of this. First, I'm going to use my area formula. Remember, that's going to be pi r squared. We know that the radius is 3, so that's 3 squared times pi. I know 3 squared is going to be 9, and I know pi is 3.14. Now I simply multiply these together. 3.14 times 9, that's going to equal 2826. I remember that there's two circles, so I'm going to multiply this to 2. That'll give me the total area of the circles. 5652. All right, let's go to the rest. Again, we know that the width of this rectangle that's going to wrap around it is 2. We need to do the circumference formula to find out the length. Circumference formula is going to equal 2 radiuses times pi. We know that the radius is 3, so this is 2 times 3 times pi. 2 times 3 is 6. 6 times 3.14 will give us the length. So we're going to take 3.14 times 6. That's going to equal 1884. Now we know that what the length is, we're going to have to multiply this to the width, which is 2, to find out the area of a rectangle. That's 3768. Now we just have to add these two together to find our answer. All right, let's try it. We've got 37.68. We're adding that to 56.52. That gives us 94.2. So this is 94.2 feet squared. All right, let's go to number 11 next. All right, number 11 is much of the same, except they give us a diameter this time. So we got actually made it a little easier in some ways, harder in the others. Harder in the way of finding for the area of a circle, because remember the area of a circle is pi r squared. But since we know our diameter is twice as big as radius, we could just take 6 and divide it by 2, and that'll give us our radius, which is 3. So now we have pi 3 squared. I would do all this work, but look right over here. We got the same formula, pi times 3 squared. That equaled 28.96, and when we multiplied it to 2 to get both circles, we got 56.52. So that tells me all I need right there. This is all going to equal 56.52. Now I got to come over here and I see that this is 12 centimeters long. I need to find the circumference, but luckily, again, the circumference formula is right over here with that radius that we had of 3, right? And we said that this radius was 3. So when I find the circumference formula, remember that was 2 radiuses times pi, right? That's going to give us the same thing right over here, 2 times 3 times pi. And we've got the answer, so I'm not going to do all the work. This is going to end up being, let's see here, 18.84. Now, some might say, Mr. Meadows, I thought it was 37.6. But remember, we multiply this length times this width. That's where this 2 came from. That wasn't part of this formula here. So we're going to have to take this new number and multiply it to 12 instead. All right, so we're going to take 18.84 and we're going to multiply it to 12. And And that's going to equal 226.08. Wow, sorry about that. 226.08. I'll double check my calculator on that one. Yep. And now we're going to have to add that to 56, 52. Plus 56.52. That's going to equal 282.6. 282.6. Double check that. Yep. And that's going to be centimeters squared. All right, let's go to number 12 now. Number 12 says find the lateral surface area of each cylinder. The lateral surface area of the cylinders. Okay, and that's a little bit different than what we got here. This one was find the surface area of the cylinders. This one's saying to find the lateral surface area of the cylinders. First, you need to know what lateral means. Lateral means what is it says the surface area, the lateral surface area. So we're talking about the area of this rectangle. Okay, I guess I'll shade it in to make it kind of obvious. Basically, all of this part. Okay, that's what they're looking for. They don't want to know what the area of the circles are. They want to know what's the part that's going around. And we already kind of have a formula for that we came up with. We realized that to find that, we have to go ahead and take the circumference, right? So that's diameter times pi, which we can turn into radiuses times pi. And then we're going to multiply it to the height. And in this case, it's 6, right? So we're taking this formula for circumference, 2r pi, and now we're going to alter it and multiply it to 6 when we're done to get the lateral surface. When I do this, remember, I can multiply across all the way. And let's remember, radius is 10. So now we have 2 times 10 times 3.14 times 6. All right, I know that 2 times 10 is 20. Now I have 20 times 3.14 times 6. I'm going to put this in parentheses over here and over here because I know that all these dots get kind of confusing. I know 2 times 6 is 12, so this is going to be 120 times 3.14. Let's see, 120 times 3.14. Wow, I just realized I was doing one of yours. So I've got to stop there. That was a pretty big jump for you guys to figure out what to do there. I have number 13 to do, and you'll have 12 and 14. Just follow along. Can't believe I did that. We're going to use that same formula, though, okay? Remember, we had pi. We're multiplying it to the diameter, or 2 radiuses. And then that's going to give us the circumference. Then we're multiplying that to 9. So the radius is 4. So now we have 2 times 4 times pi times 9. I know that 2 times 4 is 8. And 8 times 9 is 72. So now I have 72 times 3.14. Let's try that. Looks like I got my calculator taken away there. There we go. So we're going to take 3.14 I'm going to multiply it to 72. That's going to equal 226.08. 226.08. I'm going to double check to see that's what was on my calculator. Yep, 226.08. And remember, that's going to be inches. And since it's area, inches squared. For those that would want to round it out, I mean, you could say that it's very close to 226.1, right? Pretty close to it, inches squared. Let's go ahead. Remember, you have 12 and 14. I'm going to go to 15. It says, what is the surface area of this cylinder? Okay, well, I know that I'm going to take all of this, right? I've got to start with the circles. The circles was pi r squared. So that's going to give me pi times 5 squared. I know 5 squared is 25. Now I got 25 times pi. I know that 25 times 3.14. That's going to give me 78.5. And I multiply this to 2 because remember, if this is 78.5, then the bottom of the circle is also that. So I'm going to multiply my answer times 2. That gives me 157. Now I have to find the area of this rectangle. We know that we need circumference formula. That's going to be 2 radiuses times pi. The radius was 5, so this is 2 times 5. 2 times 5 is 10. And 10 times pi, well, that's 10 times 3.14. That's going to equal 31.4. Now I simply add these together. Wait, sorry. I forgot. Now that I found the length all the way around this, I have to multiply it to the height. So I have to multiply this to 10.6. So now I'm going to take 31, sorry about that, I put 31.4 times 10.6. And that's going to give us 332.84. 332 point, is that 84? 332.84, yep. All right, I forgot to put the decimal there, sorry about that. So now that I've got that, I've got to add that to this number over here, 332.84. We're just going to add these together. And when I do, I see I got a 4 there, 8 here. Decimal comes down. 7 plus 2 is 9. 5 plus 3 is 8. And 1 plus 3 is 4. So this looks like 489.84. That's none of these answers, is it? Now it says, what is the surface area of the cylinder? Notice now, they left pi as part of their equation. So I wish I would have looked at those a little earlier. What we have to realize is we multiplied this to pi, let's see, over here, right? And over here. So in reality, what we have here is, let's see, pi, let's look at our formulas at the beginning, pi times 5 square, right? And we'll be adding it to 2r pi, right? And then times, remember, when we got our answer, we're multiplying it to 10.6. So times 10.6. So now we're going to go ahead and Realize that 5 squared is 25. So now we got pi times 25. That's going to be added to. We've got, let's see here, 2 times the radius. We said the radius is also 5. So I'm just going to put 2 times 5, right? And then I'm going to put pi over here. And I'm going to multiply this to 10.6. All right. So let's multiply all that together really quick. That's going to give me 2 times 5 times 10.6. That's going to equal 106. So now we got 106 pi. And now we've got 25 pi plus 106 pi. We can, remember, these are like terms now with pi at the end. So I can put 25 pi over here and add these together. We're all talking about pi, so in actuality, this is going to be 6 plus 5 is 1. Carry the 1. This is going to be 1 plus 2, that's 3. And 1 comes down. And now we have 131 pi. That's still not any one of these answers, you might say. So we're going to have to dig a little deeper. When I look at my formula for the circles, I realize I did everything right. Pi r squared, which was 5 squared, that's 25. I got my answer, and then I multiplied it to 2 over here. All right, so I'm going to have to realize I've added another, let's see here, another 25, I guess, right? And let's see, pi is still there. So this would have been 6, 5, there we go, 156. I forgot to add that other circle in, which made it 156 pi. Our answer is D. All right, number 16 is yours. I got number 17 here. It says modeling real life. The Petri dish shown has no lid. What is the surface area of the outside of the Petri dish? Okay, outside of the Petri dish. The surface area of the outside of the Petri dish. All right, to do this, I'm going to try to make that formula right the first time. We know that the area of a circle is pi r squared. But we know we have 2 circles this time, so I'm going to multiply this to 2 to keep me from making that mistake I did last time. Then we've got the circumference formula, which was, let's see, 2 radiuses times pi, and we had to multiply that to the height. The height of this looks to be 15. I think I've got all the variables in this time that I need. So let's remember the radius is 50. This radius is also 50. But see, I'm multiplying this 50 times 2. And then multiplying to pi, then multiplying it to 15. I'm multiplying this radius square, which is 50, right? Square to pi and to 2. We know that pi is going to be 3.14, so I'm going to leave that for last, because remember we can add these together at the end. 50 squared, 5 times 5 is 25, so this is going to be 2 times, let's see, 25 with 2 zeros after it, and then times pi, and that's going to be added to, let's see, 2 times 50 is 100, 100 times 15 will be 1500 pi. So 2 times 20 or 2,500 would be 5,000 times pi. Now I can add that to 1,500 times pi. Since pi is at the end, I can add these together and get 6,500 times pi. Well, 6,500 times 3.14 gives us 20,410. 20,410 millimeters square. But as I'm looking at this figure here, I realize there's really no lid to a petri dish, is there? So, you know what? I think we're going to have to remove this 2 and leave it as 2,500. I'm going to have to apologize. I'm pretty sure that this would give us too big of a number because we don't have a lid to this. So that would mean this was wrong. I'm just going to erase it. Save me some work here. I'm going to replace it with 2,500. And then when I put these together, I'm not going to get 6,500, am I? I'm going to get 4,000. So that's going to change everything. Now I got to take 4,000 and multiply it to pi to get my new answer. Let's give that a shot. 4,000 times 3.14. That's going to give us 12,560. 12,560. All right, number 18 is yours to do. I've got number 19, and then you have number 20. Wow, we still got a little ways to go, don't we? Number 19 says, a ganza is a percussion instrument used in a samba music, okay? Find the surface area of each of the 2 labeled ganzas. We've got 2 of them here. They want us to add the surface area. I'm going to save on a little time. I've decided to go ahead and paste some work in because I see this video is getting really long. So the first ganza that we do, we see that the surface area is, let's see here, looks like, and I'm just going to bring this one image up so we can see it better. Yes, it looks to me like they've given the diameter here is 3.5. So half of 3.5 is 1.75. So what they did here is they took the formula, 2 times pi r squared, because we've got 2 circles that we're doing, right? And then the radius was 1.75. When they multiplied 1.75, when they squared it to that times 2 is going to give you 6,000 or 6.125 times pi. Then over here they took the circumference formula. That was let's see, 2 times the radius, right? And the radius was 1.75, so 2 times that times 10, because the height was 10, will give you 35. 35 times pi, right? So we're going to take 35, add it to 6.125, then multiply that to 3.14. That gives us 41.125. Actually, we're adding these 2 first by the looks of it. So 35 times 6.125 is 41.125. We multiply that to pi, we get 129. Let's see, 1325. And that's about 129.1 square centimeters. So now we're going to go ahead and check out the other one. It's much of the same of what we did a second ago, but we're using the length, the radius, which is half of 5.5, that's 2.75. And we're using the length, which is 24.5 over here. When we do all the math, we get about 470.6 square centimeters. Now, this says find the surface area of the 2 we did. Now it's asking the smaller ganza weight is 1.1 pounds. Assume that the surface area is proportional to the weight. What is the weight of the larger ganza? I'm going to do this once again. I'm going to take the work and get it in here quick so we don't have to spent a lot of time watching me write it. We're going to take the uh, weight. Remember, it says the smaller gallons is 1.1. So that's 1.1 here. And we know that the area was 41. You see over here, 41.125 times pi. The bigger one was about 149.875 pi, right? So we're putting that over x. You might have wondered why we put it to pi. We're just making it a little easier when we do the math later. We're cross multiplying here, right? We're taking 149.875 and multiplying it to 1.1. Remember how to cross multiply. So we're taking this and multiplying it to this on the bottom. And then we're taking this here, the x, and multiplying it to this one here. Erase that, show it straight. All right. Double it so it actually looks blue. And that's going to be 41.125 times x. When you take these numbers and factor them out, you're going to take 149.875, multiply it to 1.1, right? But since we've got an x here, it would be smarter to do our division first. So we're going to divide 41.125 away, and I'm going to show that math here because they're really not showing how they got that. They divided this away, 41.25, and they went ahead and divided this number by it because they both had the same pi, right? 42 or 4.25. Sorry, 41.25. 41.25. When you do that, you're going to get 3.64. I'm going to show you right here. Remember, we're taking 149.875. We're dividing it by 41.125. As you see, we get about 3.644, right? And now we're multiplying that now that we've gotten rid of the pi, see, because the pi was over here, right? Yeah, we're dividing that out, and that's going to give us the times 1.1. When you multiply 3.644 times 1.1, you get 4. So the weight of the larger Gonza is about 4. Okay? All right, let's go ahead and go to number, let's see, 20 is yours. I've got number 21. The cylinder has a radius of R and uh, the height of H. How many times greater is the surface area of a cylinder than both dimensions are when both dimensions are multiplied by 2, 3, 5, and 10? Once again, to make this a little bit easier, I've taken all of the answers to each and put the work here. We see that when you multiply it by 2, right, a factor of 2, you're going to take all these and multiply it by 2 and get that as your formula. When you multiply it by a factor of 5, 4 times, or this says 3, I'm sorry. The surface area increases 4 times greater when you have a dimension multiplied by 2, all right? And remember, it's almost like when we have a picture, right? And I say, how many times is this picture, when I multiply it by a factor of 2, going to go into itself? Well, that's because this is going to go into it 1, 2, 3, 4 times. We're going to make it twice as wide and twice as tall, right? So when I multiply by a factor of 2, 4 times greater. When I multiply by a factor of 3, 9 times greater. When I multiply by a factor of 5, 25 times greater. When I multiply by a factor of 10, 100 times greater, because 10 times 10 is 100. B says describe the pattern in part A. Write an expression for the surface area of the cylinder when both dimensions are multiplied by a number x. And once again, I'm just going to pop that work in there. When both dimensions are multiplied by a factor of x, the surface area increases by a factor of x squared. In other words, whatever you put in here, like 2, we have to square it, there will be 4. When it was 3, we squared it, it was 9. When it was 5, we squared it, it was 25. When it was 10, we squared it, it was 100. Okay? The expression for the cylinder, when both dimensions are multiplied by a number x, would be the following. X squared, whatever number it is, squared, times our formula. All right, guys, that was all of them that I had to do. Good luck with the rest of them that you have to do. Sorry for the long video, but some work takes a while. Have a great night.